Hello again, everybody. Today we're going to be looking at sequences, and as we get started with sequences, the first thing that I want to tell you and assure you is that this lesson is the least important lesson in all of expressions. Okay, so every lesson that we've covered so far, the lessons we're going to cover until we're finished with expressions, sequences is the one that you're going to be asked the least amount of questions about. It is the least important. I really like it because I think it's kind of fun. It's a different way of thinking, and some students get it just like that. For some students, it takes a little bit of time to understand. So this is different. We're going to use expressions to help a little bit with sequences, but I do want to let you know, if you struggle with this lesson, do not freak out, do not get upset, and you don't need to panic because it is really, in the grand scheme of things, not that important. And you're not going to have a question like this on any quizzes or tests, okay? So I'll assure you of that. Okay, but first of all, what a sequence is. A sequence is just an ordered list of numbers. Okay, so I'll give you all a minute to write these down. Pause your video, write these down, and then we'll come back and talk about them. Okay, so like I said, a sequence is an ordered list of numbers, and the same thing is happening every single time you do a sequence. You're always multiplying by 3. You're always adding 10. Something like that. You all have used sequences before, I'm sure. A term is each number in that sequence. So the third term of a sequence is the third number in the sequence. And then an arithmetic sequence, it is a sequence where you find the next term by adding the same number each time. So you're going to add 3 every time. You're going to add 5 every time. Something like that. That is called an arithmetic sequence. Okay, so the first thing I want to do is just get into some of the examples. So our first example here, describe this relationship between the terms in the sequence. 4, 7, 10, 13, and so on. And then we'll write the next 3 terms. So the relationship is you are adding, you add 3 to the previous term. 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13. And then the next 3 terms will be 13 plus 3 would be 16, 19, and 22. Okay, so that's just using a sequence, adding a certain amount to the next, to each previous term. So go ahead and pause your video, and I want you to answer the same questions about this term, this sequence. 1, 1.3, 1.6, 1.9. Okay, so for this sequence, you would be adding 0.3 to the previous term. And the next 3 terms of that sequence would be 1.9 plus 3 would be 2.2, and then 2.5, and then 2.8. Okay, so that's an arithmetic sequence, and that's what you're doing. So this is kind of an intro to sequences as we get started with it. So when we're going to use expressions when talking about sequences. Okay, so first thing, we can write expressions to represent one of these arithmetic sequences. We're going to use n as our variable every time, and this table will help us. So we're not going to fill this out right now. Okay, all you need to get down are the position, operation, and value of term. Pause your video if you need to. Okay, and we're going to look at our first example here, and I'm going to show you how this table will help us. Sometimes we might need to do 1, 2, 3, 4, and then n, if that helps us kind of visualize what's happening. But we're going to look at how this table will help us write expressions for sequences. So our first example, the greeting cards that Meredith makes are sold in boxes at a gift store. The first week, 5 boxes were sold. Each week, the store sells 5 more boxes. So if that pattern continues, we're going to write an expression to represent the total number of boxes sold after X weeks. So instead of n, we'll use X. But what we want to do first is write our chart. So position, operation, and value. Okay, so our first position will do 1, 2, 3, and then X. That's how it'll look like. Okay, so what I would suggest doing, okay, is we've got our table right here. What I would suggest doing is figure out the value first of all. So what is the value after the first week? What's the value after the first week? How many boxes were sold? Well, it would be 5. So we're going to write 5 right here. Okay, after the second week, how many boxes were sold total? Well, after the first week, the store sells 5 more boxes, so there'll be a total of 10. Okay, after the third week, how many are sold? Well, 15. Okay, so what are we doing to go from 1 to 5? We would be doing times 5. So I'm going to do times 5. From 2 to 10, times 5. From 3 to 15, times 5. And so, times 5, which means it would be x times 5. How would we write x times 5? It would be 5x, right? And so that right there is our answer, 5x. So in order to figure out how many she sold after any number of weeks, you would do 5 times the number of weeks, or 5x would represent that expression. Okay? So let's look at our next one. Write an expression for the following sequence: 3, 6, 9, 12. So I want you all to pause your video if you're feeling like you can do it, and I'll even write the table for you. So position, operation, and value. So it's going to be 1, 2, 3, 4, and we'll do n. Okay. The value is going to be 3, 6, 9, 12. We don't know what n is yet, so we got to figure out the operation, use that to figure out the value. So pause your video. I think you all can get this one. Okay, so if you notice, to go from 1 to 3, you're going to do multiply by 3. From 2 to 6, multiply by 3. 3 to 9 times 3. 4 to 12 times 3. So it's times 3 for all of these. How would you write n times 3? Well, you would do 3n. So that would be our expression, 3n. 3 times whatever is n. So first position, second, third, fourth. So for the 50th position, you would just do 3 times 50 and would get 150. So we don't even have to keep counting 50 times for this one. We would just figure out what that expression is. This is how it helps us. And then we can just plug in 50 for the 50th term, and that's going to tell us what that's going to be. Okay? So the last one here, the last example, this one's a tricky one. Okay? So we're going to go back to that first example that we did. We're going to write an expression for that sequence. So this is where I said for some students, it comes like this. And other students, it's a little harder to understand. So we're going to make the table first. So, I'm sorry, not value. We're going to do position, operation, and value. So we're gonna, let's do 1, 2, 3, 4, and n. Our value, the first position is 4, the second position is 7, the third position is 10, the fourth position is 13. So what's gonna be the nth position? Okay, so let's look at that. And I would say you try to figure this out on your own. See if you can get it. From 1 to 4, you would multiply by 4, right? Times 4. But does that work for 2 and 7? Doesn't work for 3 to 10. Doesn't work for 4 to 13. So we're not just multiplying by 4. Okay, so let's think about something else. How could you go from 1 to get 4? You could do 1 times 2 plus 2, right? That would work. So what about this? 2 times 2 is 4. 4 plus 2 is not 7. Think about that. If you want to pause your video and try to see what you can come up with, don't take too long. Let's see if you can come up with something. So this is what we're going to end up doing. We're going to do 1 times 3 plus 1, right? 1 times 3 is 3, and 3 plus 1 is 4. 2 times 3 is 6. 6 plus 1 is 7. Does that keep working? 3 times 3 is 9. 9 plus 1 is 10. 4 times 3 is 12. And 12 plus 1 is 13. And so the operations that we're using for this would be multiply by 3 and then add 1. So the way that we would write that with n would be 3n, 3 times n, plus 1. That is the expression for that sequence. I know that's a tricky one, kind of hard to understand sometimes. And so as you work on the examples, if you're struggling with it, it is okay. Remember, you've got questions, get on the Google Meets and ask me. I got office hours that you can ask me about as well. But see what you can do. This is kind of more of a fun type of lesson or section. Remember, this is not the most important one that you're going to be looking at, and you're not going to be quizzed or tested over sequences. So just kind of see what you can do with that.